All right. Hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. Today we have radical equations part one. It's like the easier version of the two. And don't let that be a detriment if you're already kind of struggling with this and you're like, oh man, I can't even understand the easy stuff. We're going to break it down so that it's even easier and work through all of these questions together. So, in order to solve any equation ever, I've talked about this before, but the opposite of PEMDAS is SIDEMAP. So you have PEMDAS, right? And most everybody is familiar with this. If you're not, it stands for parentheses, exponents, multiply, divide, add, subtract, which is the order of operations. That's how you simplify stuff. So like if you're doing one thing at a time, no equation necessary. Now, equation necessary, SIDEMAP, when you're trying to solve things. You do PEMDAS backwards. You do it the other way around. You try to add or subtract something on both sides first, then try to multiply or divide something on both sides, then try to, do exponents. And then if there's stuff inside of an exponent or whatever, that would be parentheses. And just like in PEMDAS, where there's another PEMDAS, if I can spell, here we go, PEMDAS. Just like how there's another PEMDAS inside of a parentheses, there's another SIDEMAP inside of a parentheses as well, right? So pretty much same exact thing, just backwards, right? Inside of a parentheses, we're going to look for another SIDEMAP. Okay, so if all of this looks a little bit confusing still, and you're like, wait, PEMDAS, SIDEMAP, what's going on right now? There's another video on this, on simpler equations. When you're solving, let's say, one-step equations, that's when I really went in detail about what SIDEMAP is and how to use it. So if all of that is new and you want kind of a precursor step to this, I would check out the one-step equations video. You can get that from the playlist that's at the end of this video here. So you can just scroll to the end of the video and you can find that playlist in the cards. Or there should be a video for the one-step equations that is its own card at the end of the video as well. So if you want to check that out, scroll to the end, grab that, watch that video first. But without further ado, let's go ahead and solve this. This is actually going to be a one-step equation here. The opposite of a square root is a square. All right, so we're on the E step of SIDEMAP. There wasn't anything to add or subtract on both sides or divide or multiply. We square both sides because the opposite of a square root is a square. You do opposite operation. You do the opposite of whatever the thing is that you see on both sides so that you can eventually pick away, so to speak, until you get to the answer. So x squared, square root, those guys cancel. And you just have x equals 100. Right? 10 squared. Don't forget, it's not 10 times 2. It's 10 times 10. All right, let's see a lot of people make that mistake. Be really careful. It's not 10 times 2. 10 times 10. And that's it. Right? You might be thinking, but what if isn't there like a thing where you have to do like a plus or minus somewhere? And there is, but that's if you have to take the square root of both sides in order to solve. Not if you square both sides. Okay? So I know it's kind of nuanced a little, but if you square both sides, you don't do plus or minus. If you square root both sides, then you do a plus or minus. Okay? So if you were asking, I don't know if you were. If you were, then that's the answer to that. So let's go on to number 2. This one is going to be a two-step equation. Okay? Because when I square both sides, I get 100. All right, same thing as last time. But when I break this open, when I break open that square root, it kind of reveals that there was like a parentheses. There was like a grouping, right? So if you generalize parentheses, it would really be grouping. G instead of P. M over 10. All right, so I did the E part. Right, I did this E part here. But then I'm not done because m's not by itself. I have to do multiply by 10 on both sides. So you might think, if you're following SIDEMAP, like, oh, I would do multiply on both sides first. But you don't. You do P, right? So we did E, and that unlocked the parentheses. That exponent unlocked that parentheses, and now we can go inside the SIDEMAP again. That's why we multiply by 10 on both sides after we square. 10 times 100 is 1,000. And that's what m is equal to. And we're done. All right, and as we go along here, I'm going to just keep switching colors. I usually switch colors about every 2. I don't say super consistent with that, but I try to. As we go along, if we come across something new, I'll pause and go a little slower and explain the new thing, but as long as it's not something new, I'll start to go a little bit faster. 1, so that you're not bored if you already got this and you're like, all right, why is he going so slow the whole time? And then 2 for runtime, and then 3 because I want you, no matter where you're at, to be able to understand this at all levels. All right, so I went a little slower for 1 and 2. Let's look at 3 here. So we square both sides still. Right? There was nothing else to do besides square the square root thingy. Right? So 3 squared is 9. Right? 3 times 3. And then I've unlocked that parentheses. And now I add, oh, why did I put 5? I don't know why I put 5. That was dumb. Add 4 on both sides. Don't ask me how I got 5 out of 4. And 9 plus 4 is 13. There we go. Okay, so same thing for number 4. Square both sides. All right, that cancels. 6 squared is 36. V minus 2. I'm going to add 2 on both sides. If I skip the middle step, I would just get straight to this. Okay, you don't always have to show that middle step. Eventually, you want to get to where you're not showing the in-between steps because it's just kind of tedious. Okay, so let's go ahead and go on to the next color and the next set. This is going to be the same thing. Square, square. 9 squared is 81. The reason why they have this here is because it's tempting to like square root it, because 9 does have a square root, but you don't square root it just because you can. It's actually 9 squared, so 81. Done. Actually wasn't that bad at all. 5 squared is 25. X plus 3. Subtract 3 on both sides. I get 22. Boom, done. Okay, nothing new yet, so I'm not going slower. I'm actually going quicker as we go. Let me know in the comments if one of these questions I went by too fast. And I'll go a little slower on that kind of question next time. So I know. Give me some feedback. So 2 squared is 4. If I square the square root thing, it goes away, and then I divide both sides by 4. Right. This is a little bit different, but not by that much. We square both sides, and then once we unlock the square, this one was a little bit different in that after we unlocked what was under the square root, we had to divide on both sides. But that's pretty much the same as this, right? And this is just like what we did before. You unlock the square, what's under the square root. You unlock what's under the square root. 1 squared is 1. And then you do whatever operation you need to do, the opposite operation, in order to solve. All right, and that's it for that. So on to the next. Okay. Here, oh, this is different. Okay, so we're going to pause for a second because this is different. Number 9 is different. It's different because every other time, let me scroll back here. Every other time we've done this, the first step has always been to square both sides. Okay, that's always been the first step. Here, that's not going to be the first step because of SADMEP and SADMEP again. SADMEP. I'm going to use a G here for grouping. I mentioned that earlier, but I actually like to use G for grouping because you don't actually technically see a parentheses, right? So grouping is a more general term that's actually more applicable. Okay, so as we look at this problem here, there's a couple different operations, right? There's a plus, there's a 5 times, there's a minus 5, and there's a square root. So there's actually 4 things, right? There's 4 things. I'm adding -8. I'm subtracting 5. I'm multiplying 5, right? 2 different 5s there. And then I'm also taking the square root. So there's actually 4 operations that are happening to the variable, which means there's 4 steps. However many operations there are, that's how many steps you're going to have. Okay, so what we want to do then is we want to add 8 to both sides. Add 8 to both sides. And then that's the opposite of -8, right? So I add 8 to both sides. Square root of 5a minus 5 equals -3 plus 8 is 5. If you need some help with integers, I'm not going to really talk about integers that much in this video. If you need help with those are also in the playlist. Just click on that playlist. It's one of the first videos in the playlist. It says the title of the video is either adding and or subtracting negative numbers. Okay, so if you have trouble adding and subtracting negative numbers, go check that out. That's in the playlist as well. But now that we've added 8 on both sides, now I can square both sides because there's nothing else to do until I unlock what's underneath the radical. 5 squared is 25. Square root, the general term for square root is radical. So that's where I got that from. So then I add 5 to both sides. Okay, 5a equals 30. Divide both sides by 5. This one was a doozy. 30 divided by 5 is 6. All right, that was a lot of steps. That was 4 steps. Right? 4 operations, 4 steps, but still doable. You just got to follow SADMAP. So let me recap. That was we added on both sides. Okay. Then we did the square root thing, or the square. We squared both sides. That was E, which unlocks the grouping. Right? We have some stuff under a radical that's a grouping of things. Then we did adding on both sides again. We added 5 on both sides. Then we divided both sides by 5. Okay, so you see there's the 4. Now this G, this is just unlocking groupings. That's not its own step. There's 1, 2, 3, 4 steps we did there. Okay, so that was a lot. And let me know, of course, in the comments if you want me to explain more problems that are like that are a little more complicated. But we're going to get to more complicated problems like this in the future. So just hang with me and we'll get to some more that are like number 9. This one, same thing. We've got a little bit of work to do before we unlock that square root. Okay, so this is going to be 6. Then I square. 9x equals 36. Divide both sides by 9 and I get 4. All right. Next color, yellow. So number 11 is actually the same as what it always has been before 9 and 10. We just square both sides first since there's nothing else to do before that. Add 5 to both sides and you get 6. All right, again, I'm going to go a little faster on questions that we've already talked about. So number 11, that was a little bit faster. Okay, I'm going to divide by a negative 10. You just divide by the exact same thing. That's going to be positive 6, square. V minus 10 equals 36. Remember, it's 6 times 6. And then V plus 10. We plus 10 on both sides, so 46. And there's the answer. All right, we're on the second page. And at this point, I don't think it's going to get, well, actually, this looks a little complicated right here. So it will get a little bit harder as we go here, but hopefully not by that much. These are all going to be, right here, these are all going to be pretty similar to what we've already done. So I'm not going to go and explain them that much. It's going to be 3. Then we square. Right, so 10m minus 1 equals 9. We are going to add 1 to both sides and then divide by 10. M equals 1. All right, cool. So then for this one, same thing. Divide both sides by negative 6 first. Then we can unlock that square root. Square both sides. 2 squared is the only time that you can actually multiply 2 by 2 and get the same answer, because 2 squared happens to be the same thing as 2 times 2. But that's the only number, well, actually, besides 1, that you can do that to. So anyways, that cancels. B plus 4. If we subtract 4 on both sides, we get 0. All right, so that's the answer to that. Going to a more stronger English. A more stronger version of this. It was like a gold. Now we're doing orange. Okay, so we add 1. Oh, I broke my own rule. I wasn't going to show the in-between step. Oh, well. It's 8. Square. V plus 3 equals 64. Subtract 3 on both sides and you get 61. Over here, we're going to divide by 9 on both sides first. Right, divide by 9 on both sides. Then we square. And then we divide by 25. And there we go. Right? And this is about as fast as I'm going to get, because you really can't go that much faster. Okay, number 17. This is, well, actually, oh, the bar goes all the way across. I didn't see that the bar went all the way across. It does. It is still going to be a little different because we have square roots on both sides. But we just square both sides. And the square goes away on both sides. So not that big of a deal. 3n equals 4n minus 1. We have ins on both sides. That's a little bit different, but that's in normal equations without squares and square roots anyways. So I'm going to just subtract 4n. I'm going to show the in-between step just because this is a little weird, but hopefully not by that much. So if negative n equals -1, then n equals 1. And that's how you solve that one. Same thing here. We're going to square both sides. So it gets rid of the square root on both sides. Right? So not too crazy. Now, we have a fraction. Nobody really likes fractions that much. And if you agree with that statement, then here's what you need to do. Multiply both sides by 6. Right? So the alternative to fractions is larger numbers. So if you're okay with a larger number, then go for it. I actually don't know what 6 times 88 is off the top of my head, so I'm going to multiply that over here. 8 times 6 is 48. 8 times 6 again, so 48 plus 4, which would be 52. So 528. 528. Pretty big number, but if you're like me, you probably like big numbers better than fractions. Right? It's the lesser of two evils. So if I subtract 12, I get -11. And then I would divide both sides by 11, and that would be 8 times 6, which is 48. So 48 would be the answer to that. If you can't use a calculator, you could divide this. I kind of just use a little math trick. I have other videos where I talk about how to do math tricks, but that's what that was. I was just kind of doing some math magic in my head there. All right, square both sides. 3x minus 58. So again, we have this whole like, I need to either get big numbers or keep the fractions, and I'd rather have the big numbers. This one's not bad at all though, because I'm multiplying by 10. When you multiply by 10, you just add a 0 to everything. So we have this, and then we'd have -29x equals -580, and I'm assuming that goes in evenly, but I don't know how many times. Well, you would have to multiply it by 2 to get 58, so 20. Cool. So x is 20. Over here, and again, I'm not going to explain how I'm doing all the mental math as much because I'm assuming you can use a calculator. I'm not, just because I didn't feel like it. But obviously, if you can use a calculator, why not, right? So I'm going to subtract n on both sides, 1 n on both sides, so I get 2n. If I subtract 12 on both sides, then I get -4. N equals -2. Again, let me know in the comments if I'm going a little too fast. This video is a little bit of a faster video just because I'm a little bit more crunched for time today to get this out to you, if I'm just being real. So that's why I'm going a little bit faster. So if I need to make another video like this that kind of explains what I'm doing a little better and a little slower, I will. Just let me know in the comments if that is something that interests you. If I add x to both sides, I get 2x over here. If I add 7 to both sides, I get 18 over here. So then x is 9. All right. So then, well, the next color would be white, but that's not going to show up. So let's start going the other way. I think I started with blue, so we're going to go to indigo now and then go in the opposite direction. So square both sides. Same as before. Times both sides by 5. Just like before with the other ones. 5 times 72. There is a trick to multiplying by 5s, actually. You take half of the number and then you add a 0. So half of 72 is 36. Add a 0. Pretty cool, right? That works on any number. And then we add 5 to both sides. 5x to both sides, that is. So we get 6x. If we divide by 6, we get 10. Oh, sorry, 60. JK, LOL. All right, 24. X plus 3 equals 1 minus x. Add x to both sides and I get 2x. Subtract 3 on both sides and I get -2. Divide both sides by 2 and I get -1. Okay, and I believe these are the last ones. Ah, they are. Okay, so again, this is nothing new. These are just the last two, so they're just, they got some more stuff going on, but no big deal. So 2k plus 40 equals -16 minus 2k. We're going to add 2k to both sides. We get 4k. Subtract 40 on both sides, and I would get negative 56. Then I divide by 4. And if you divide by 4, the trick to that is taking half and then taking half again, assuming you can take half pretty easily. So half of 56 would be 28. Half of that is 14. So we have that. Square both sides over here. X plus 8 equals 3x plus 8. Oh, look at that. The 8's cancel if I subtract 8 on both sides. So this is kind of weird, but if I subtract x on both sides, I would get 0 equals 4x, which means x would be equal to 0 because 0 divided by anything is 0. And that kind of makes sense. If you plug in 0, I'd get the square root of 8 equals the square root of 8. So there we go. There are all of the answers, and just in case you didn't believe me, here are their answers in red. And yes, you have access to this too. All I did really was just Google this, all right? You just Google the title of whatever math thing you're on, and this Kuta worksheet thing will pop up, and it'll have the answers on it. A lot of times your teachers give you these worksheets, and they don't have the answers included because they don't want you to know what the answer is. But you can know what the answer is just by looking it up. Not that you should cheat or anything like that. You want to show your work so that they know you know how to do the thing. But knowing what the answer is when you're first learning a new topic can be really helpful because then you can at least work backwards from the answer. So hope that's been helpful. Like, subscribe, all of that. And I will see you in another episode